Okay. So we are on 3.2. I'm going to go full screen. And here we go. Transmission. What does transmission mean? Wendy, have you heard about transmission? What is transmission? What does transmission mean?
The data sent from one device to another device.
Yes. Transmission is basically 你可以写 in your notebook. Okay? Woman, you can use your iPad to write. Jed, you can use your notebook. Okay? Transmission is how we send the data. What type of data are we sending? How is data sent between networks? Yeah, we can use wireless. We can use wires. Okay, so we have different mediums. I don't like that. I'm gonna go hot pink. You guys like hot pink, right? Oh, it didn't change. So we can send data through the air. That's using waves, okay? Or we can use cables. Okay, that's using wires. There's basically only two ways to send the information. Now, when we transmit, we actually send the data in packets. Okay? Internet packets. It's basically you have a whole bunch of ones and zeros in a packet where you have part of the packet will be like an IP address, then you have like your data, and then you also have some other data in there. Okay, so it's split up into different packets, and it's basically when we're studying data, we're studying binary. Okay, so we're going to be talking about how does data. What are the different techniques to send it between different computers on the network? Okay, so I'm going to describe the different methods of transmission. Data transmission is basically you have a sender receiver, and then, okay, how do we send the data? We can have that, okay? This is just a quick overview. We send, Wendy, I don't want you to look at the laptop, thank you. The laptop is just for reference for the PowerPoint, nothing else, okay? HDMI, what type of data is sent on HDMI? Does anyone know? HDMI, this port, what kind of data is sent? Yeah, it's HE, is high definition media something. It's used for the TV, for video. Okay? Modem is for the internet. Okay? You have a VGA, this is for display. Okay? We have serial. That was like the olden days. We had a serial port. We have USB. Okay, that's also it's basically serial data. So we're gonna watch a quick video of the difference between serial and parallel. Let me just. I'm going to open it. Oh. I think that this is an image. So let me think. I'm going to minimize here. I'll actually have to go to the real PowerPoint. Okay, so we are computer science, grade 11, networking, and networking transmission. I'm gonna have to put these hyperlinks into the OneNote so that I can just click it in the future. It'll be easier. And then I don't have to use the PowerPoint. Okay. Here we go. There we go. Oh no, I can't read. Okay, this means play, I think, right?
我係阿朱啊，主要專研究港股資金流向同板塊輪動。今日港股出現明顯分化，指數平穩，
It's
但
playing.
北水繼續淨流入，科技板塊同中特股輪動加快，部分高息股成交放大，反映資金正重新部署。
USB. One of the wonderful conveniences of modern life. You just plug it into any one of the similar looking ports and things just work. Well, most of the time anyway. But whatever happened to those old school massive things we used to use to connect printers and hard drives? Well, older standards like IEE 1284 and IDE cables had so many pins and took up so much physical space because they communicated in parallel, meaning that they could send and or receive multiple bits of information simultaneously. By contrast, new school interfaces like USB, SAS, SATA, and individual PCI Express lanes are serial, which, fun fact, is actually what the S in each acronym stands for. These ones can only send or receive one bit at a time. But wait a minute. Why on earth would that be better? I mean, when they close all but one lane on the freeway, that's a bad thing. Well, popular parallel standards had a number of limitations that slowed down their real-world speed. These ports depended on all of the data lines sending the correct data simultaneously. So trying to push more and more data through a parallel port per second means that it's harder and harder for those lines to stay synchronized, meaning that as you increased the data rate, the port actually had to slow things down and wait for all of the signals to match up. Another phenomenon called crosstalk also complicated matters. Crosstalk is basically electrical interference between data lines that are close together, and it becomes more pronounced when you add more lines than again when you try to make them faster. Because a serial connection like USB only has one data line in each direction, crosstalk isn't nearly as much of an issue. This means that although serial connections can only fire off one bit at a time, the rate of fire can be made much higher, especially as electronics manufacturing in general has improved. So think of an automatic machine gun shooting tons of bullets per second, one at a time, versus a break barrel shotgun that can fire lots of pellets at once, but has a much longer reload delay. Parallel connections also had the disadvantage of using lots of pins to support transmitting multiple bits at once, and that meant that the connectors themselves were more prone to damage. Think about how easy it was to bend printer pins or an IDE header on an old motherboard. Modern serial links typically don't use protruding pins, making standards like USB and SATA suitable for, many more insertions, as they say. But Linus, hold on a minute. What about my fancy new graphics card that uses 16 PCI Express lanes at once? Isn't that parallel? Well, not really. Each PCI Express lane has its own clock signal, so they're not synchronized with each other. The data is simply transmitted down each lane in a more independent fashion, leaving the card itself to sort out the information, which doesn't take very long, meaning that PCI Express speeds scale very well as you add more lanes, which you can see in high-speed PCI Express devices like solid-state drives and video cards. Pretty incredible, right? Well, that may be. But as far as one bit at a time serial technology has come, I wouldn't bother trying to eat your bowl of Frosted Flakes one at a time. Do you really want your ISP keeping an eye on what it is that you're doing online? Use TunnelBear. TunnelBear VPN.
What is serial? There's two types of data transmission. One is serial. Another one's called parallel. What's the difference between serial and parallel?
Serial is like single bit for one time, but not distance. Parallel is like multiple data transmitted, but short distance.
Very good. Can you write this down in your notes? Serial can only send 1 bit at a time. And basically you only need to have 1 wire. This is good. What are some, okay, what is parallel? What does parallel mean? Uma, what is parallel?
More than one bit can be sent at a time.
Yes, parallel is, in fact, it's actually faster than serial. It can send multiple bits at one time. How? Well, it has more than 1 wire. How? It has multiple wires. But there's a problem with this. What is the problem with the parallel? Can anyone tell me? What is the problem as mentioned in the video about parallel? Parallel is faster, but there's a problem with parallel. What's the problem? Yeah, say a little louder, I couldn't hear. Yeah. Yes, that's one good point. It has so many pins that when you put in the cable, like the IDE connector on the old computers, is easy to break the pin. Very good. Anything else? Okay, so this is serial. Let's just write some good thing about serial. Okay, it has less pins. Okay. What are some other good things about serial? It only has 1 wire, so it's cheaper. It's 1 wire. So it's cheaper. And it's used for, as Wendy said, it's for long distance. If you want to send data on the internet, is this serial or parallel? What do you think? Wendy, if you want to send data on a network really far away, is this serial or data?
Serial.
It's serial because we're just sending it on the internet. We can use waves or a cable. We're not going to be having multiple parallel packets at the same time. That's why packets have to be split up. The data that is transmitted is cut into packets. What is the packet, Ched? What is a packet? Have you heard about a hongbao?
Yeah.
A hongbao is a packet of money. So it's basically you put some money into an envelope and you send it to someone, right? And so that's how the internet works, is you put the 1s and 0s into a packet. Now, parallel has multiple wires. It has multiple wires. Uma, what is something that, so therefore it's the fastest. The fastest is because I can send everything at 1 second, 1 time, it's there. But there's some problem. Uma, tell me, what is the problem when we have multiple wires in parallel sending between 2 devices?
There could be interference.
Yes, and that interference is called what? Cross something.
Crosstalk.
Yes, but it has this thing called crosstalk. What crosstalk is, you have these electrical magnetic fields that will induce some 1s and 0s into the other line. And this corrupts the data, and then I have to resend it. And so it is faster, but it has crosstalk. What is some other downside of parallel, Wendy? What is some other problem? Crosstalk is an issue. What is the other issue? If I had to go long distance and I have parallel, what's the problem?
You only can send the data in a very short distance.
No, I I can put parallel lines really far, no problem. But what would be the issue with this idea?
The data will be broken.
Okay, we have crosstalk. What is the other issue? Think about money. How many wires do you need? Parallel needs multiple wires, one wire per bit, right? So it's going to cost, it would cost a lot for long distance. Long distance. Very good. The CPU, the bus system, Uma, is the bus system serial or parallel? What do you think? How many wires are on the bus?
It's parallel.
Yes, the bus system is an example to the CPU is a system of parallel. It's a short distance between the RAM and the CPU. And why do we use parallel, Chet? 为什么是 parallel? Why would we use parallel when we're talking from the CPU to the RAM?
Why?
Yeah, you tell me. We use multiple traces wires. Why do you think why don't we just use one wire? I'll open up the computer. Do you remember how we have these wires? Why?
Which one?
Right here, we have many wires that go to the green stick. Why do you think we have many wires? Do you remember seeing the bus system?
Because there's many battery needed to go in.
Okay, why parallel, not serial? Why is it not serial? Why is it not serial? Why do we choose parallel? By the way, Wendy, how many lines are on the bus system? How many wires on your computer? In the olden days, we had 32x. We have 64. Okay, so why is parallel? Because it's faster. We need to transfer the data between RAM and CPU fast, so therefore it's parallel transmission. Does that make sense? And it's very close, so it's not too expensive. Okay, serial parallel, no problem. Uma, how many wires are on your laptop? Any idea? What is your bus system? It's probably 64. It's 64 is the 32 is like the old ones without multi-core, long time ago. 64 is the common one now. Okay. Here's some examples of some old parallel ports. You don't need to copy this down. Just have a look. What is this device there, Ched? What is this hardware? Have you ever seen a hardware like this? It's an old one. Yeah, this is a printer. Okay. The old printers used any idea, Uma, what is the name of this port? The old printer ports were what? Serial or parallel? Yes, how do you know that this is parallel? Because you have multiple pins. If you see multiple pins, you already know it's a parallel transmission. Okay? So if on a test they ask you, give me an example of parallel port, you can say printer. Okay? The old printer ports were parallel. Okay? Wendy, what is crosstalk? There's a problem with parallel transmission. What is crosstalk in your own words?
Just like two or more wires close together and the electrons goes into the second wire due to magnetic field induction, and that will break the data.
Yeah, it will change data in the other transmission line. Maybe a 1 becomes a 0 and a 0 becomes a 1. So crosstalk is basically when you have some data from one line go to the next through induction. Exactly, from those magnetic fields. And therefore, we put this. What is this there, Uma? This little thing around the wires. What does this do? Any idea?
Is it to protect it?
Yeah, this is actually to stop the magnetic fields. They put a little sheath around it, okay? It's called shielding, okay? What does shielding do there, Chet? Why do they put a little piece of metal wrap around wire? They put shielding. What does shielding do? Any idea? As I have the wire go, he has a magnetic field. Magnetic fields, they like to go through what? I don't know. Have you studied about physics? Are you in physics?
No.
No? Electrons like to go through metal. So if I have metal here, the magnetic field will go, the electrons will go into the shield. And so that's going to protect my wire. Does that make sense? Okay? So you can see that there's this little metal wrapped shield, and that's to protect from external and internal interference when electrons are moving through the wire. Okay? Okay, there's a new thing I want you to write down. What is in the world skew? So in your notebook, skew, what is this? This is a 1, 1, 1, 1, right? This is serial or parallel there, Chet? Is this serial or parallel transmission?
Parallel.
It's parallel. You're correct. How do I know that this is parallel? How do you know that this is parallel? There's multiple things. The second problem, parallel has two problems. One is called crosstalk, right? So in your note, make sure you understand crosstalk. The other problem is called skew. Now we're talking about skew. What is skew?
When each wire has different differences or like different.
Yeah, they have different resistance or different lengths. And so what happens to these bits? Do they arrive at the same time? This is the destination. Skew is when bits don't arrive at the transmission at the same time. Let's write this down. Skew is when bits, okay, this is the definition I want you to write in your notebook. Okay, skew, place it. Okay, so right here, write down crosstalk, right, how skew. And I just want you to write in your own words. Do not copy from the PPT. Remember how I taught you how to study? Write the notes, right? Make it simple. Skew is when bits arrive at different times. And this is a problem because what am I going to have to do? This is a problem. If these bits, and I want to get the message, what is going to happen? Even though the data arrive faster, what am I going to have to do with skew? Can I read the message right away? When I get this first bit, do I know what the message is sent on the transmission line? What am I going to have to do? If I have skew, what am I going to have to do? I'm going to have to wait. Right? This is going to, even though the bits send faster, I have to wait at the end to receive all the bits because they didn't arrive at the same time. This is a problem. We have to wait. Now, there's a second fix, and this is something interesting. I designed circuit boards, and there's a way to fix this. One solution is wait, but waiting is the worst idea possible. Is there a way to make all the bits arrive at the same time without waiting? Can anyone think of an idea?
You store it somewhere
Like a buffer, yeah? But we're going to still have to wait through a buffer. That's correct. So waiting through a buffer. Oh, yeah, that's really good. That's the same idea with the time. I'm going to show you a magic solution. They don't tell you in your textbook, but it is a solution. Okay, Wendy, can you quickly have a look? Normally, when you send, you have a wire, but each wire will have a different thickness. Agree or disagree? Right? And so we have this, it's called resistance. And even though I have the same wire, one wire may be a little bit fatter than the other, maybe a little bit thicker. And therefore, you're going to have slightly different resistance. And so the data is going to, one will be fast, one of the data will be faster than the other due to resistance. There's a quick fix. You know what we can do is we can physically change the length of the wire in the computer. Because this one's faster, I need to slow him down. Agree? And so what I can do with this wire is I'm going to make his length a little bit longer. Okay? And this one, since it took a little bit slower, I'm just going to have it one length. Now, when I send the data, he arrives at this time, and I've calculated how long it takes to go through here, and he arrives now because the resistance is the same. So other way is just to make sure that the wires are the same length and the same properties. And you'll see these little squiggly lines on the circuit board with them doing that. Let's see if I'm correct. I want you to look at the bus on the circuit board and see, do you see the squiggly lines on the parallel? Have a look. Can you find the bus system between the CPU and RAM? Right here. Are those lines straight? Oh, look. This one's easier to see.
Yeah.
What do you notice about those lines? Are they straight? Why are they not straight? What in the world are they doing? Are they crazy? Why are they squiggly line?
Skew.
It's because they're fixing skew on the RAM. Cool, right? And so when you look at the thing and you're like, it looks like they're on the RAM. It looks like they're going crazy. Those lines are going everywhere. But they're fixing skew so that those bits arrive at the same time. Okay, check skew in your notebook. Make sure you understand skew. Okay. Skew. Yeah, you can find the Chinese thing. And this is a really good example. Where's the skew shown? How to fix skew is basically on your RAM. On your RAM, you'll see that those data lines, they put these little they don't really look like that. They look like kind of like wavy. And what are they doing that? Is this so the bits arrive at the same time? Okay? So an example is in RAM, they put different length, and they're trying to fix this. So can you summarize there, Uma? We can fix by waiting. What is the other solution? What can I do about the wires? What is this? What am I doing when I increase the length of the wire? What property am I changing?
The distance, like the time will change.
Yeah, because the resistance is going to change. The longer your wire, the more harder the electrons are to move through it, right? And so when we get the same resistance, that means that the bits are going to arrive at the same time. Okay? So let's write this down. You can either wait or you can change. What can I change? Length of wire. To get the resistance yanda. If the resistance is the same, they're going to arrive at the same time. So in your notes, just put 2 ways to fix skew. 一个 is 等一下, just to wait until all the bits count. The other thing is to change the 线 to make the 线一样的长. To make the length of the wire the same width, the same length. Okay? Okay. Now, okay, we already talked about that. We have wires, we have SATA. Okay, now we're on transmission direction. Okay. Okay, last thing is we need to talk about how the data is sent inside the wire, okay? And there are three methods that we can send data on the wire. Okay, Wendy? One is called simplex, the other one's called duplex, and the other third one is haplex. And I'm going to explain this and then we'll summarize it at the end. Okay? So, the most easy one is called simplex. This is Jendan. It's simple. Okay? So, simplex, let's just write this down. Number one, in your notebook, 写 simplex transmission. Simplex transmission, data travels only one way. You can think of this as a one-way street. Only one way. One way. So when you're studying this, go simplex is equal to one way. Done. You do not need to write a whole bunch of information. You just have to remember simplex transmission is when data only can go one way. The data cannot come back. And this is actually an idea that used in the USB. In the USB, we actually have a universal serial bus. This is just an example. We have 5-volt line, and then we have a TX. TX means to send, and then we have a RX. RX means to receive. And then we have a GND. Okay? So this is the negative. Okay? This is positive. Is USB serial or parallel transmission? Does anyone know? You know the USB? Yeah. The USB, if you have a look, can you look in there? How many wires do you see inside the hole there? Have a quick look. How many wires do you see? There's 4 wires. How many wires do you see in this USB stick? 有几个? How many wires? Can you count? Have a look in there.
4.
That's 4. USB stands for universal serial bus. And it's the most common, it's plug and play. In fact, universal serial bus has 4 wires. One is the positive, one's the negative, and then we have transmit. You see, transmit can only send the data what direction? Can it send the data back? No. This is an example of a simplex transmission just on one line. Okay? If I was looking at a TX line on a USB port, this is called simplex. The TX can only 送东西，不可以接东西。Okay? Now we also have receive. Receive. So this is the data go this way. Receive is when the data comes back. Again, this is an example. If I was just looking at this one 线, this is an example of a serial simplex transmission. Agree or disagree? Simplex just means one direction. One line, one direction. Okay? Next, we have half duplex transmission. Half duplex transmission means that we still just have one line. We have one wire. 但是 we're going to take time on the road. We have a green red light kind of idea where we can go and then we'll have to have a control it to stop, and then the data can come back. Half duplex, 你需要写 half duplex transmission is one wire, but the data can go to the device and back on 一个线. Okay? Let's just write that down. So the data can be transmitted and received. Oh, this should be Rx. Okay? Therefore, we have to take turns. Okay? Let's write it down. Data can be transmitted and received. 但是 but we need to share the wire. Therefore, we're going to have to wait. This is a problem. What is the problem, Chad, with half duplex? What is the Wenti? If we only have eagle loop, but you can go back and forth, what is the problem if we only have one road? If the cars go this way, can these cars come back at the same time?
No.
So therefore, the problem is we have to wait. This is the problem. But tell me something good, Uma, about this idea. A halfplex, what is something good about it? Yeah, a good thing is you can go back and forth. And the other good thing is it only uses one wire. We can save money. We don't need two wires, right? Like a USB actually has two wires. We can go back and forth, okay? That's called full duplex. Half duplex is only if I had one wire and you had the transmit receive there, okay? So halfplex, you have to wait. Okay, now the last one right here. This is number 3. In your notes, you're taking good notes, right? In your notebook. Full duplex, data can travel on both directions at the same time using 2 cables. This is an example of my USB, okay? USB is an example of this, where I have a TX transmission, okay? And then I have a receive. That means that USB is the most popular type of transmission on your computer. It's universal. It's 很方便. If I have a mouse or a keyboard, they all use the USB port. Agree? This right here is full duplex. That means when I plug it in, my device can send data to the computer and back at the exact same time. Okay? Let's write this down. Who can tell me what is full duplex?
It's a way of transmitting transmission that's simultaneous.
Yeah, can send data. Can send data. They use this big word. Simultaneous means that the 一样的时间. Simultaneously. You want to learn a new word there, Ched? Have you ever heard this word before? This means same time. This is a good word. Full duplex can send data simultaneously. Simultaneous means 一样的时间. Can I do this there, Wendy, with 一个线? Can I do simultaneous transmission with one wire? Is it possible? It's impossible. Okay? This requires how many wires there, Ched? 这个线. How many wires do I need? How many lanes do I need to send at the 一样的时间?
2.
Yes. Let's put this in our definition. Let's put this in there. Can send a diamond to the same time. Therefore, you must have 2 wires. What is the names of those 2 wires? What is the sending? What is the notation for sending and receiving there, Uma? What is the sending wire called? What is this right here?
The transmission.
Yeah. It's transmit and receive. Okay? The 2 names of this is called transmit, T for transmit, and R stands for receive. Okay? We call it TX because it's maybe a 1 or 0. Right? That's just the notation of the communication. Again, we're talking about networking, we're talking about wires. Wi-Fi also has a transmit and receive where you're studying waves. It's the same idea. You can have fullplex, dualplex, simplex. Okay, I'm going to ask each one of you, what is halfplex? Wendy, halfplex. What is halfplex?
One wire by both directions.
Good. Tell me simplex. Chet. Simplex. Look in your notes. I'm doing a review with you guys. There are 3 methods of transmission. What is simplex?
Data travels in one direction.
Good. Uma, fullplex.
It's a bi-directional simultaneous transmission because it uses 2 cables.
Yes, very good. We use 2 cables. Very cool. Okay. I think we're good. We have parallel. Again, we have parallel serial, but the idea is we have 3 methods that can work. Simplex and dualplex can work on both ideas of serial parallel. Okay? So you just have to remember serial, parallel, and then in here there's actually 3 methods. One is simplex, one is half dualplex, half dualplex, duplex. And the third one is full duplex. Okay? And this one, if you're studying here, Wendy, I'll give you a little cheat sheet. You just need to remember the name and put a little arrow so you understand. An arrow represents a line. Does this make sense there, Chet? Simplex is just 一个线,一个路, one way.
One way.
Half duplex is 1 wire, 2-way. I think that's very easy to remember. Agree or disagree? And so when you're studying, I don't want you to copy a whole bunch of things. I just want you to put the important information. And full duplex, it just means you have a TX, RX. If you can remember these pictures, you understand how many wires, and you understand the idea. Okay? Just using a simple summary is going to save you when you are studying. Okay, so let's just put the yes. Sometimes we do get errors, but I'm going to talk about that later. Okay, let's just put the summary. So here's the summary. What are the 2 types of transmission? Uma, what are the 2 types of transmission that you can have?
Serial.
Yep. You can have serial and parallel. Okay? And then in here, Ched, what are the 3 types of transmissions that you can have within that? We have 1, 2, 3. Yep.
Simplex,
Simplex, half duplex, full duplex, and then this is one direction, this is one wire this way, and then that way. Oh my goodness. This is TX, RX. You see, in this lesson, if you can just remember this, you don't have to look at anything else. And so be very careful when you're copying a PowerPoint. Don't copy PowerPoint. You just need to copy the idea. And when you're studying, just study this. How long is it going to take you to remember this? Not too long. Have some keywords. You need to have some keywords when you're studying. And have some image. Because we're humans. For us, it's very easy to remember image. And so when you're studying and you have a summary, just summarize your notes. And I encourage you to write. Okay? Write in your notebook is because on the exam, are we going to be typing? On the exam, am I going to be typing simplex, duplex? What am I going to be doing on the exam? You're going to be writing. And so therefore, I want you to try to write using your pencil or pen because on the exam, that's how you encode the information is how you retrieve the information in your brain. And so if you are typing and then you're not typing, it's not the way you encodified the information in your brain. So when you're studying, you just write serial, write it down. And then simplex, write it down, because you will have to write those keywords on the test. Okay, that's it. Your schoolwork / homework. Okay? Your homework is 3.2. We're on networking. Okay? Please do read a little bit about some collision. There's some collision, okay? This is a little bit of schoolwork, okay? I want you to read about collision, about the data. We're going to talk a little bit more about that later, okay? So you can open up your homework, your laptops, unit number 3. And you'll see that I have uploaded here. What is the difference between serial and parallel? Write it down if you can. I really like the tablet. You could use the tablet and write it down. You could use your notebook and write it down. However, but we're going to submit this on here. You can hit draw. I love OneNote. So if you, on your computer, you can say, serial, you can just write, right here. So if you can write on your computer, that'd be great. That's it. Okay, I'm going to stop the recording. Okay, stop.